This video is brought to you by Sporlan. Quality, integrity, and tradition. All right, I want to start this off by giving a disclaimer. Do not, under any circumstances, try what I'm about to do. I do not want anybody to get any ideas from what I'm about to do. I'm doing an experiment. I was in a controlled environment. I was very safe about what I was doing. Do not try to be an engineer. Do not try to, redesign things if you don't know what you're doing. I'm an idiot. I clearly don't know what I'm doing, but I'm just kind of making some assumptions and some guesses here, okay? To give some context, I'm going to be doing an experiment here where I take a R-290 refrigerator, completely operating, actually brand new, that long story short, the customer asked me to dispose of, but I decided to use it to do some experimenting stuff on. I am going to be taking this R-290 refrigerant. What I do is I remove all the R-290 from it. I pull a proper evacuation, make sure that it passes a decay test, and the video is going to start with me weighing in new R-290. I'm going to weigh in the factory charge, and then the video will pretty much lay out the rest of what I'm going to do. Okay, so the video is going to start off with me weighing in the brand new R-290 charge, and then after that, we will go through the experiment and try a few things, okay? All right, so we're getting ready to charge this guy. This unit takes 113 grams, and one thing that I will say is, kind of crappy, is most scales won't read and the increments pass like 105, 110. They don't, like this one won't say 113, so you kind of got to figure it out. I've already purged right here, so we've purged that. We're going to zero our scale, and we're going to go ahead and charge it in. The system's still in a vacuum. We're charging in on the high side, so it should take quite a bit. And in fact, we actually need to go ahead and purge right here. There we go, just to get the air out. We're good. Okay, so now we need to go ahead and zero it out. And we're going to go ahead and open this guy up. Actually, I should have. Yeah, we're good. Okay. Make sure it's zeroed. And then we're going to open this guy up, and we're going to 113 grams of R-290. I'm pretty sure it'll pull it all in because we're in such a good vacuum. Liquid R-290, so it should pull it in pretty good. Go ahead and let that happen. I still don't have probes on here. We'll put those on here in just a minute. We just want to get this guy charged up, and then we're going to take some vitals and see how long it takes to come down to temp with R-290. And then we'll go ahead and remove the charge, vacuum it down again, make sure we have a proper evacuation, and then we'll go ahead and put 134A in it, and then do the test to see, how well it works with R-290 versus 134A. All right, it's getting dark outside, but my unit is starts in a defrost, so I'm going to pop it out of defrost right now, and we're going to fire it up. Unit just fired up. I'm going to start the stopwatch on my wrist. Okay. What we're going to do, this unit has the factory charge in it, brand new. I weighed it in from a proper vacuum, like you guys saw. I'm monitoring evaporator superheat. I am monitoring discharge temperature, liquid line temperature, outdoor air, and then obviously the pressures. We're going to see how long this unit takes to come down to temperature, and at what, from the factory, we're going to benchmark the settings when we figure out what kind of an evaporator TD and condenser TD that they run with R-290, and then we're going to mimic those numbers when I put 134A in. So essentially, if this thing runs with a 15-degree condenser TD, then we're going to mimic that with 134A, or attempt to, and the same thing for the evaporator TD. And then we're going to time the pull down time from startup. My box is, I have had the doors open for quite a while, so my box is 57 degrees inside right now. So we'll mimic those tomorrow when we pull down with 134A. All right. We are at 22 minutes and the unit has satisfied. So let's just call it 20 minutes. Yep, satisfied and happy. All right, so I let this thing run overnight, came back out, it's down to temperature. Again, this has R-290 in it. And with the factory charge, our numbers are not crazy. I mean, I have no set idea as to what the numbers would be. I've not talked to the manufacturer. So just off of the factory charge that's weighed in, you can see that as my expansion valve opens and closes, my subcooling changes, which would be expected because this system does not have a receiver, so it's using the condenser as the storage device. So the refrigerant backs up in the condenser and then leaves the condenser depending on how much the expansion valve opens and closes. So that seems good. I set my benchmark temperatures based off of the evaporator and condenser TD of the unit operating right now. My box temp, I just opened a door to bring the box temp up a little bit because it was just about to satisfy, but it's coming down in temperature. This is what we're seeing. We're seeing pretty normal. The expansion valve is doing its job, adjusting the superheat. It's trying to maintain about 10 degrees superheat. And when I opened the door, it, changed and all that. But subcooling, I've seen it anywhere from 10 to 15 degrees. Yeah, everything's looking good. So the next part of this step, so this is a fully operating R-290 system. I'm going to take some thermal imaging videos of the condenser and of the evaporator, and then we're going to get some current draw of the unit, and then we'll continue on with the test. We're going to go to thermal image mode right now. And what we have here is our condenser coil. Doesn't look like anything's too abnormal. This is the evaporator. Nothing crazy looking. So, yeah, I don't see any problems with this, and everything seems to be operating properly. Last thing, I took the cover off the condenser so we can get a better thermal image view. And I've got the Redfish 550 meter on there, and I'm measuring the total power usage of this unit. I've removed the R-290 charge, and I'm sweeping the system with nitrogen. Going to agitate the compressor a few times, try to get any R-290 vapor out of the oil. This way, I am never, theoretically, as long as that nitrogen is dry and has no moisture, I'm never introducing moisture into this system, and I'm simply just sweeping with nitrogen from the R-290. So basically, I vented the R-290 charge, which is totally legit, and then left a slight amount of pressure in there, hooked up the nitrogen, purged it as I was screwing it on, vented it, and now I'm just purging with nitrogen. So now, there theoretically should be nothing but nitrogen in the system. And now we're gonna do an evacuation on it. Okay, you can see we're like coming down at a funky angle. And what you'll notice, so you see my microns, I'm only pulling from one side at this moment. But what'll happen is, move this over here. I'm only pulling from one side at this moment. But you'll notice that what happens when I shake the compressor, that number jumps because the nitrogen in the refrigerant now is boiling out of the oil. So what we're gonna do, we can do some things to speed that up. You can just continue to agitate it. You can heat up the compressor with a crankcase heater, with a heating blanket or something like that. I happen to have a heat gun. You gotta be careful though, because this had flammable refrigerant in it. Now it's just vapor, but it still might have pockets. So I have a heat gun on there, and I bet you anything we see a spike in a minute once it heats up that oil. So right now we're at 5,300 microns. I'm very carefully heating it up with the heat gun, making sure it's not gonna melt anything else. And I bet you once that compressor gets hot enough, you'll start seeing that micron reading go up. It'll probably be reflected in the graph more than likely. I'll show you guys when it pops up. There was a little bump because trapped vapor, refrigerant, and nitrogen is popping out of the oil. But it's coming down. Now I'm only pulling from one side. I'm gonna go ahead and open up this other side because I wanna speed it up. It is gonna make for some funky numbers with the vacuum. You notice now that I open that up, it's gonna start dropping really fast. And that has a lot to do with the micron gauge being so close to where the hose is connected. So another thing I didn't do is I didn't open the gas ballast, but it's okay. See, we'll see a drop now, and yeah. All right, I'm gonna show something real quick. So you see little spikes, and that's all the vapor boiling out of the refrigerant, the nitrogen and the out of the oil, the nitrogen and the refrigerant. But if we come up here and we look at this, so I opened this core removal tool up so it was pulling from both sides, but to get a true reading, I need to close it. But this is gonna just show you how important it is to have your micron gauge hooked up to the right side. So even though it was reading really low, once I valved it off and now it's only getting a true reading from the other side, look at how high it's climbing, because that wasn't an accurate reading. The reason why the micron gauge was so low was because it was connected too close to the hose and it was actually getting more pull from the vacuum pump than the actual true reading of the system. All right, this is my final decay test. I'm gonna go ahead and call it at this. It's slowly rising, but I think we're gonna be okay. So I'm gonna let it decay for a few more minutes and just make sure that we don't climb too high. And then we're gonna go ahead and put the 134A in the system. All right, I don't think it's gonna get too much better than this. I don't want to spend too much time on this guy. It's slowly rising, but I guess I should technically make it the decay test. Continue decay test. And let's see what we're doing here. So, decay rate is 0.6, 0.8. It's kind of bouncing around, dropping down, 0.3. You know, I kind of wonder if there's moisture in the nitrogen or the refrigerant. Who knows? But I think this is about as good as it's going to get. Mind you, we are at 378 microns. So, I mean, technically, from the looks of it, it kind of looks like it's still got some kind of non-condensables or moisture in there. But I'm not an expert. But, I mean, it's just a gradual rise, and it kind of looks like it's tapering off to me. So we're going to call this and go ahead and charge this guy with 134A now. So we have a clean, dry system. Everything's zeroed out. I've purged all the way up to here, and I slowly had it cracked while I was putting it on, so that way it's not getting any air into the system. We're going to zero out, and we're going to start with the factory charge of 113 grams that the R-290 had. We'll put 113 grams of 134A, and then we'll see how the system operates, and then we'll go from there. We got to zero this guy out though, because it's kind of bouncing around. Okay, so we're charging on the high side. Let's start. You see it's 10 increments of 10, so you're not going to see the whole 113. Again, 100, 110. We're going to have to go 120 and stop, because that's the increments that it does it in. So we're at 120 grams. We're going to go ahead and start this guy up and see what happens. Okay, I can go ahead and take off the micron gauge because the system's under pressure now. That way we didn't introduce any unwanted moisture or air into the system. I'm going to put this guy on here. All right, so this is kind of bouncing around, but I went ahead and moved it over to the suction line, so it still has the measured refrigerant we put in there. Our box temp right now is 47 degrees. Let's go through our numbers. It's been running for about 2 minutes. So outdoor ambient 68. Superheat is extremely high. Subcooling is non-existent. Suction line. And we need to go ahead and set some metrics and come up with, I need to input the evaporator temperature, or the evaporator TD, like we had on the other one. So I'm gonna do that real quick. Okay, I've got my targets in there. We were running a 30-degree evaporator TD and about a 25-degree condenser TD, give or take a little bit there. So that's what we're trying to mimic right now, but obviously we have no subcooling. So what that means is that we're feeding vapor to our expansion valve. So we have to get that subcooling number up. I'm gonna aim for about 10 degrees subcooling in hopes that it brings my superheat down too. So we're at about 120, 110 grams. So we're just gonna add a little bit more and see what we have to add to get our numbers about where they need to be. All right, it's been a few minutes. I've added some refrigerant. I'm currently at 330 grams. So mind you, I've gone way over the recommended amount of R-290 refrigerant for this system, and that is just trying to get this thing to have some subcooling. So currently where I'm at right now, we currently have a 15-degree condenser TD. We're aiming for a little bit higher, and we have an 11-degree evaporator TD. We're definitely aiming for higher on that one. So let's go ahead and go back on over to these numbers and look and see. My box temp is 41 degrees, all right? Outdoor air temp is about 68 degrees. But look at, I still have 0.5 degrees subcooling, 1 degree superheat. So we're flooding back to our compressor right now. But the problem is with that low of subcooling, we're still likely not feeding liquid refrigerant. We're still feeding some vapor to that expansion valve, okay? And look at our targets too. Based off of our condenser and evaporator TD from the operating R-290 system, we're way above our numbers on our targets. Now, this is kind of getting a little bit closer to what I would expect a normally operating R-134A system as far as the pressures go, but I'm trying to look at temperatures and the saturation temperatures and my subcooling number and my superheat number. You know, everything's kind of out of whack here if you look at this. And this, in my opinion, is because this system was not designed for R-134A. If you pay attention, R-290 condenser, if you look at a comparable R-134A condenser, the amount of heat rejection capabilities that that condenser has is a lot bigger. The condenser tubes are a lot smaller. This isn't even 1/4 inch, I don't think. I think this is something smaller than 1/4 inch. And look at it, it's just a single, or actually it's only 2 passes through the condenser. But you know, the condenser's smaller, the evaporator's smaller, the compressor's smaller. So by putting 134A in the system, in my opinion, it's not working. All right, and you know, yes, I'm sure we are getting some cooling, and it is cooling, but it's not right. And in my opinion, it's not safe. All right, we're not the engineers that made this box. In my opinion, we can't go just dumping refrigerant into this just because we think that someone on Facebook or something like that told us that, yeah, you can take out R-290 and put 134A in. All right, the simple fact that we had to put in more than double the amount of the manufacturer's suggested refrigerant with R-134A alone sounds like a safety issue to me. I could only imagine in the summertime what's going to happen when they get a really hot kitchen. Now, granted, this unit's not meant to operate in the outdoors, but this, in my opinion, is proving my point that you cannot put 134A safely in an R-290 system. Yes, you can just keep adding gas and it might work, but is it right? No, not in my opinion. I'm going to keep this test going, and we're going to keep these numbers going and see what we can get to. All right, we are at 520 grams now is how much I've had to add to get my subcooling close, and I don't want to overshoot my target. So I'm currently at 9 degrees. It's kind of bouncing around. Mind you, that subcooling number is going to change as the expansion valve opens and closes. 1 degree of evaporator superheat. That is not compressor superheat. My compressor is ice cold right now because we are flooding refrigerant back to it. So the refrigerant, the evaporator, in my opinion, is not big enough, and the expansion valve is not sized correctly to boil off all the refrigerant needed to give us the subcooling. I mean, it's just a hot mess, this whole thing. It's never, I mean, you're never gonna, it's just not gonna work right. All right, so I'm not gonna add any more refrigerant. We're at 9.8 degrees subcooling, and we're watching the system. Now, just looking at the pressures, it doesn't look horrendous, but I'm not so concerned about the pressures. I'm looking at the evaporator temperatures and looking at the performance. Looking at the subcooling, look at my evaporator superheat, too low. Let's look at our condenser TDs right now. It's going over here. My box temp is at 41 degrees. Condenser TD is 14 degrees. Evaporator TD is 8 degrees. So nowhere near the TDs of the R-290. And the condenser TD, remember, that's going to be your efficiency in a nutshell, because that's the ability to reject all that heat out of the condenser with the TD that it was with the R-290, and then the heat transfer capability with the R-290 on the evaporator TD. So if we can't match those numbers, the efficiency is going down the drain. And again, I am not a scientist, guys. I'm just a dumb guy that just is just working this out. I don't know all the super technical crazy terms or anything, but I mean, this to me just adds up that it doesn't work. Again, I'm still, in my opinion, proving that this is not a safe and good practice to do. I'm gonna call this this test. It's failed. This is not working. It's not safe. Do not try this. Absolutely do not try this. I am in a controlled environment, and this refrigerator, I mean, you're tempting fate. What is the big deal about using 134A? R-290. It's really not that big of a deal. Don't be afraid of it. The system was designed for it. Now, I'm sure there's going to be people saying, well, you should have used R22 or whatever. The reason why I used 134A was because the majority of the people out there on the Facebook groups and commenting say that they drop in 134A, or they heard you can drop in 134A, once you remove the R290. And no, you can't. This is not proven. This is not safe. Look at the original factory charge was 113 grams of R290, and I have put 510 grams to get myself somewhat close to the subcooling number that I had. But look at my superheat when I do that. I mean, this is not good. Do not do it. Look at our condenser here. So pretty much the same view, same color scheme. To me, it doesn't look like, it looks like this condenser is just not being able to reject the heat. It's kind of hard to exactly tell what's going on here. I mean, I know that we're overloading this condenser with refrigerant right now. All right, last but not least, let's go ahead and look at our power consumption on this bad boy. Let me get this guy back in here. And 0.40 kilowatts, 5.26 amps. This thing is still at 48 degrees and I am still at 24 minutes. So this thing isn't even dropping in temp barely. So, all right, this just concludes. This just isn't gonna work. I'm gonna leave it running just for giggles. Let it run for a couple days and see what happens, but yeah, it's not working. Okay, so the experiment was simply to take R-290 out of the equation, put 134A in the system, and see what would happen. And exactly what I expected to happen happened. It doesn't work, okay? Sure, you can remove some refrigerant, and you will get some cooling, I'm sure. In some way or another, you can make it work, but it will not be right. And in my opinion, it will be dangerous, okay? The reason why I think it's dangerous is because we're having to put way more refrigerant than is required, than what the system was designed for, okay? The components in the system aren't meant to handle that refrigerant. It just sounds like a walking disaster, okay? And I believe that I pretty much proved it with the numbers. I started with the factory charge of R290 with the 134A, put the 113 grams in there, and it obviously wasn't doing anything. So then I added refrigerant slowly, trying to obtain the vital signs numbers that the system was performing with the R290, okay? Again, I kind of mentioned it in the video, but the reason why I did this is because I see an overwhelming, what I consider to be a ridiculous amount of people saying that you can simply remove R290 and put 134A in the system, okay? And I think I've disproved that. Now, I'm sure that someone, like I said, can go ahead and put 134A in and it might work half-ass, but it's not going to work correctly, and you're setting yourself up for a major issue. I don't think anything's going to explode, but certainly it's not working correctly. I imagine that you're going to reduce the amount of compressor life. With my unit running as low as superheat as it is, I'm sure that we're going to wash the oil out of that compressor and create some problems. We're going to end up ruining the compressor eventually. Okay, so for the customer's sake, let's just go back with R290, what belongs in the unit. Don't try to be an engineer, okay? I really appreciate you guys taking the time to watch these. Couple things I want to mention. Number one, I am part of a group of YouTube creators that has created a Discord server. On this particular Discord server, it's just a community. It's a way to continue the conversation that goes on in the comment section and in the live chat section of a live stream, okay? But it doesn't have to be during a live stream. There's going to be a link in the top of the video show notes for the particular Discord server. If you guys are interested in communicating with myself and the other creators, okay? There's a bunch of other creators that happen to be, my fake internet friends, right? That, I communicate with on a regular. We all kind of set this up together, and it's just a way for us to make ourselves available to talk to people. So check it out. If you just click the link, it'll download the app and all that good stuff, and you'll be directed. You feel free to ask questions. Also, I am starting a new YouTube channel. I've been mentioning it for a while. It's HVACR Tools. The link to that will be in the show notes of this video too. Really appreciate a follow. I'm going to start uploading to that very soon. I'm sure this video is gonna, raise a lot of questions. Bring them on. Let's talk about it. Send me questions, emails, comments. I do live streams Monday evenings at 5 p.m. Pacific time, work permitting. So long as I can get off work, I'll be there to do the live stream, and we'll talk about this stuff, okay? All right. Yeah, I guess that's it. We'll catch you guys on the next one, okay?